Today we are going to see about what is orthogonal transformation of symmetric matrix of diagonal form. Uh, Let us discuss about this topic. The transformation n transpose capital A n is equal to D is known as orthogonal transformation or reduction, where n is normalized matrix, D is diagonal matrix whose diagonal elements are eigenvalues of the given matrix. Now let us discuss how to solve the problems. Okay, there are several methods to solve this problem. Let us discuss one by one. First, we have to find out as usual things. What are the things that we have seen in our previous video? I mean, to find eigenvalues and eigenvectors. What are the steps that we have followed? All those steps we have to follow here also. The first thing, we need to calculate what is the characteristic equation. The second thing, we need to find out what is the eigenvalues from the characteristic equation. The third thing, from eigenvalues, by using eigenvalues we have to get eigenvectors. Okay, after getting eigenvectors we have to verify whether our eigenvectors are correct value or wrong value. To verify that, we have orthogonal condition, that is x1 transpose x2 is equal to 0, x2 transpose x3 is equal to 0, and x3 transpose x1 is equal to 0. If our eigenvectors satisfy these conditions, then we are getting a proper eigenvector values. After this, we have to find out what is a normalized eigenvector. For normalized eigenvector, we have a formula, that is capital N is equal to x1 divided by L of x1, x2 divided by L of x2, x3 divided by L of x3. Okay, by using this formula we can find out normalized matrix. After normalized matrix got it, then we have to find out we have to derive the given matrix to get a diagonalized matrix. To get diagonalized matrix, our formula is n transpose capital A n is equal to D. By using this formula we can diagonalize our given matrix. Okay, let us discuss a problem for diagonalized. Here we have a matrix. Our job is we need to convert this matrix as diagonalized matrix. Let us see what are the steps that we have followed to solve this problem. First, I will take the problem. Capital A is equal to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. So first we need to find out what is the characteristic equation. So I clearly explained about how to find characteristic equation in previous video. By using that method, here we can find out the characteristic equation. First, the general formula for 3 by 3 matrix to find characteristic equation is lambda cube minus d1 lambda square plus d2 lambda is equal to d3 is equal to 0. So here we need to find out what is d1, what is d2, what is d3. We have another formula, we have separate formula to find d1 d2 d3. By using that formula we can get all these values. Here our d1 is 18, d2 is 45, and d3 is 0. After finding all these values, then you have to substitute all these values in the characteristic equation. Now you have got what is the characteristic equation. From this you need to find out what is the eigenvalues. There are so many methods to find eigenvalues. You can take any one method which is you feel easy. Okay, so by help of calc, I just have calculated my eigenvalues as 0 3 15. So for these eigenvalues I need to calculate eigenvector by the given formula. As usual things, all these things we have elaborately explained in our previous video. So by help of our previous video we can find out eigenvectors also. My eigenvector x1 is equal to 1 2 2, x2 is equal to 2 1 minus 2, and x3 is equal to 2 minus 2 1. Okay, now we are going to verify whether our eigenvalues are correct value or wrong value by help of orthogonal condition. So here we have three orthogonal condition. We need to verify all these three orthogonal conditions. So first x1 transpose and x2 is equal to 0. X1 transpose is nothing but we have got the value, first eigenvector, that is our capital X1. We just write the transpose value for the given x1. This is our transpose value of x1. Then x2, then take multiplication of these two matrix, then you will get 0. So first condition we satisfied. Similarly we satisfied second and third, so our eigenvectors are correct value. Next, let us move to find normalized matrix. To find normalized matrix, just follow these table. First write eigenvector, then what is L of x, then normalized vector. Eigenvector is equal to x1, x2, x3. For x1, by using this formula, for x1 by using this formula, you can find out what is L of x1. Then for normalized matrix, eigenvector divide by L of x1. By using that formula, here my n1 is 1 by 3, 2 by 3, 2 by 3. Similarly, you can find out other normalized matrix. Now model matrix that you have to write, that is step 4. To write model matrix, our formula is capital N is equal to n1, n2, n3. We have all the values for capital N1, n2 and n3. We just here what you need to do, just substitute all these values in this matrix, then you will get this matrix value as the name of the capital N. So here what you need to do, you need to find out what is n transpose. Okay, now let us start to find a diagonalized matrix. To find diagonalized matrix, what is the formula? N transpose A n is equal to D. Just write all these matrix value and take multiplication for these trice matrix, then you will get a diagonalized matrix. This is our expected answer. Okay, I hope you have got a clear idea by watching this video to find diagonalized matrix. We will meet in next video. Thank you.